So I'll just do a revise of importing the data set. Importing data set inside R, it's very easy. If it is a CSV file, all that you need to do is use read.csv and then mention the path of the file, and then you just give the exact file name. So in the data set that I have shared, I shared a datasets folder. You don't need to download the whole datasets folder. Whatever is the dataset that is required, let's say right now we require superstore sales data. So in that there is a sales underscore sample.csv. Import that dataset. So how do we do that? We just write that path here as it is and then give the file name. But whereas if you copy paste the file name, this will be a single slash in Windows. So if I go to Windows, if I go to the exact folder that I'm looking for, datasets, so if I copy paste like this, you observe it here, you can get only this path with single line. All that you need to do is you have to copy this path and then make it double slash. So because R is built on Linux, so it is expecting either backslashes, or if you are putting forward slash, it has to be two slashes. So I'm creating sales data set read.csv just to make sure it works. Yeah, sales.csv, sales data set is imported. This works, or else I can also make it this way, or yep, sales. So I'm importing sales one, which is nothing but the same data set, but I'm using it in the Linux style. So if I put this slash, I can actually import it without any issues. So you can also see the sales one data set being created. Sales one is also created. Let me clean up everything. Let me do it once again. So sales, you can do it in this way using this double slash, or else you can also do it in this way using single backslash. If you do it in this way as it is in Windows, you will get an error. What is error? This is unrecognizable. So if you copy paste the path as it is from Windows, then you will get an error. Is that clear, everyone? Please be attentive on chat window. Is that clear? The forward slash and double backward slash, the reason why, yes. So go ahead, import this data set very quickly. All that you need to do is put the path and then give the dataset name at the end of it. Here is the code. This is how generally we are going to do it. This is the syntax that we are going to use it most of the times. We will copy paste the path as it is from Windows and put double slash most of the times. So go ahead, import Superstore sales data. Superstore sales data. Once you are done with this importing, please let me know in the chat window that you are done. As soon as you are done with the access, please let me know. Let me show it once again how to do it. Read.csv. Within brackets, I need to give the full path. How do I get the full path? I'll actually browse wherever my dataset is. So I can take this path, copy paste it there, take the file name, Copy paste it there. Okay. Now this doesn't work because this is in Windows style, so we will give the Linux style. Now this works. Make sure you are assigning it to a name. So I am assigning it to, let's say, sales. This is how that will work. This is how it works. Enter sales. You can see the sales data set here. Is this clear, everyone? Please be attentive on the chat window, then only I'll get to know whether you're following me or not. As soon as you're done, you just mention it in the chat window that you're done with the exercise. Thank you, Debashish. Uh, while you are working as a data analyst, it might be most of the times you might have to deal with the SAS datasets as well. SAS datasets have an extension of SAS 7B DAT. So how do we install or how do we import SAS datasets inside R? We need a library or a package called SAS 7B DAT. You have to install the package SAS 7B DAT. Once you install the package, then it's easy. Now understand this syntax. Whenever somebody says attaching this library, he or that coder meant to say that first install, then only attach this library. So let's go ahead and install this library, SAS 7bdat. I'm installing this library. Why am I doing that? Because I'm going to import a SAS 7bdat file, or simply said SAS data file. Now I imported the library package. I'm going to attach the library. Okay. The way that I'm going to read the SAS files is my SAS file is kept in SAS datasets gnp SAS 7bdat. I'm going to use read.sas 7bdat. That's it. Read.sas 7bdat, the complete path along with the extension gnp data. That's how I'm going to do it. And let's see the gnp data. Let me see the head of your gnp data. Here is the gnp data. That's how you import these SAS files. Okay. Go ahead, import this file quickly. Once you're done with it, please let me know. SAS 7b dot need to be installed, need to be attached using library, and then use read.sas 7b dat syntax. Write the exact file name along with the extension and the path. Make sure you give double slashes in the path. If you are using Linux, you don't need to do that. You can just use the Linux style of backslash. Is that clear? And then importing from Excel files. I would say this is very straightforward. Even if you are not done with it, just pause it. You can actually do it even later on. There is nothing really hard about this particular code. Importing it from Excel files, unfortunately, we haven't found any good library as yet, as of today, to communicate with Excel files, because Excel files, they simply don't contain just data. They have so many elements inside them. They might be macros. There can be so many other indices in an Excel file. So it is very difficult to deal with Excel file inside R. So we can try with library XLSX, library Excel Connect. One or the other error comes every now and then, says Java error or something else. Okay, so there are so many compatibility issues between R and Excel, and nobody is ready to sit and solve all of them. So none of the Excel file libraries are working as of now. If you want to try out, you can try out with these two. If you have compatible Java, R, and Excel, these codes might work. So as of now, I'm just leaving the codes with you. You can try them out, but most of the times Excel files are not, we were not able to import Excel files inside R. What if the data set is inside Excel file? Maybe either you can connect it to an SQL server, then import it, or you can save it as CSV, then you have to import it. That's the only way as of now. So bottom line, currently it is tough to import Excel files inside R. And then connecting to database server. Yeah, this is the code for connecting to database server. When you are connecting to a database server, you will be having definitely database link, and then you will be having the user ID and the password. So this is a very straightforward. You can use the code as it is. You have to use the library RODBC, and then you have to first create connection string. How do you create that? By giving the database link. So generally that database server link will be given to us. All that we need to do is we have to put it here, and then user ID, everybody will be given a user ID and then the password. Then we can write the sales data. Like when we connect to a server or a database, there are multiple tables inside that. The table that we require, we can fetch that particular table inside R, or we can even send a query. Instead of fetching the table and making it as a data set, we can directly write a query which says we have to use SQL query function. If you have really any access to any database, you can try this out. If you have access to database where you have user ID password, you can try this out. This works as it is. You can use this. Make sure you are installing RODBC. RODBC is the library or the package that you need to use. Now basic commands and data sets. Now this is very important. Please concentrate here. As soon as we import the data, there should be a way we should check whether the data that we have imported is correct or not, or there should be basic validation. As a data analyst, we should restrict the error flow right in the beginning itself. I mean, it shouldn't be like we are expecting 10,000 or 50,000 rows. There were just 20 rows that were imported and we did not observe it. Or we are expecting 400 variables. There were only 380 variables that were imported. We are expecting a variable as a numeric value, but there it is imported as a character value. Then it shouldn't happen that right at the end we realize this, oh, there is some problem, or there are some missing values in a variable, and the data set is so large that we could not directly see that by printing the data. So is there a better way of exploring the data, or are there any basic common checkpoints? As soon as you import the data, these are the things that you should do. As soon as you import the data, let's say I imported the sales data. So I imported the sales data. This is not the thing that I should do. I should not print the data as it is. Okay, because this is a small data, this works. But what if the data set is really large and you can't really get an idea on the data set. And if the data set is even really, really large, then R might even hang when you are actually printing that data set. So what is the first thing that you should do? First, import that sales data. You already imported it, right? The first thing that you should do is you should try dim, dimensions. What does dim give? It gives number of rows, number of columns. Check one. How many number of rows you are expecting, how many number of columns you are expecting. If you are expecting 100 rows and 80 columns, then definitely whatever data you have imported is wrong. Or if you are already aware that there are only 11 rows and 7 columns, then we are fine. That is step one, dim. Step two, use names, names of the data. What are the column names? That's what we should do, right? It's almost equivalent to proc contents that we are doing it manually, that's it. So what are the names? So column names, make sure all the columns are available. Step 3, since we should not print all the data set, we can print the head. We can print the head of the data. That is initial 6 observations. We can print that and see how the data is flowing, whether all the variables and their relative data, it is in the right place or not. Tail, just an alternative to head. Then structure of the data, which gives the overall variable types. Customer ID, it is an integer. Customer name is read as a factor. Customer country is read as a factor. Everything, and then unit sold is read as integer, and then date sold is read as factor. In this level, at this level, if you observe, no, date sold should be a date format, then you might want to change the format of this particular variable later on. So this gives us an idea on the type of variables. Okay, unit sold, if it is read as a character or something, then we are in trouble, right? It has to be a numeric value. If there is a variable called age, it has to be numeric. Income has to be numeric or integer. It can't be read as character. Then if it is read as character, then there is an issue with that. So in particular also we can see the structure of one particular variable if you want to deep dive. So these are some of the basic checks, and there we are not done with them yet. We can do a quick view which is slightly different from print, that will give you a separate snapshot here. I don't suggest this on larger data sets. When you know the data set is smaller, then you can use view. This is uppercase V. Or else you can directly print the data by directly giving the dataset name. This works only with smaller data sets. It's better to go ahead with smaller data sets. Now try all these commands on, yeah. So try all these commands on your data set. Try all these 6 commands on your data set. Once you're done with it, please mention it in the chat window. Then I'll go to the next topic. Cool. So that are the basic details, and then there is one more part of it. We can get a quick summary. The reason why I'm emphasizing that we should do all this before the analysis is right at the beginning of the analysis we can find out if there are any issues with the data import. So it should be a real quick hobby for us that as soon as we you know import the data, these are the basic things that we should do. We should not miss any of this. Then, I mean, if we miss this and go ahead with the analysis, we might have to regret it much later when we realize that there are some issues in the data. Issues need to be found out right in the beginning. So quick summary, we can get structure that will give the type of the variables and all that. And then we can also use something called summary. So summary will give us by each variable, it is giving us some percentiles like quartiles. So we will talk about quartiles little later. By each variable it is giving some values. Let's say sales channel, online 4, retail 7. It is giving a kind of quick summary in its own way wherever it is applicable, especially for units sold. Minimum is 14, maximum is 205, median is 116, first quartile, third quartile. So it is giving a quick summary. If you really know about this data, if you know this business, maybe looking at the summary, you can actually find out if there are any issues or any problems with a particular variable. If you find any problems with a particular variable, you can drill down that particular variable and find out that, oh no, this unit sold can't be 205, it's too high. Or unit sold can never be less than 50. Why it is 14? There is an issue. Let me check the data. Then you will contact with the guys who sent you the data. I'm just giving an example. So that's how you can do it. In fact, if it is a discrete variable or if it is categorical variable, uh, a, I mean these quartiles, percentiles don't make sense. Then you have to create a table. Okay, sales channel, how many are online, how many are retail. Then you can find out, oh, the retail is higher than online. Is it correct or wrong? Okay, you can also create the overall table for all the categorical variables. Then one more thing, we can also find out whether there are any missing values using a function is.na. Is.na finds out whether there are any missing values. Missing values, outliers, these are also one of the most important topics when we are discussing about data validation and data exploration. As of now, we will see missing values. Is NA goes to the each and every value in the data set. If it is missing, it will put true, otherwise it is false. So this is not a really smart way of doing it. What you can do is you can find sum of is NA rather than directly finding is NA. I'll use is NA, but sum of is NA. So if there are any truths, it will just calculate and add them up. If you, in particular, if you want to see are there any missing values in a particular variable unit sold, you can actually do sum of is and a unit sold. That's how you can do it. Let's do a quick exercise then. Import superstore sales data, sales by country. This time you're doing it with sales by country. Import that data set. As soon as you import, these are the quick checks that you need to run. How many rows are there? How many columns are there? Print only column names. Print first 10 observations. Print the last 5 observations. Get the summary of the data set. Very quickly do all this. First one is basic checklist after import. Second one is quick summary after import. Go ahead, do this exercise. As soon as you are done with this exercise, please ping me on the chat window. As soon as you are done, please notify me. As soon as you are done with this whole exercise. So I'm importing the data called sales by country. This is sales by country data. How many rows and how many columns are there? I'll use dim. 998 rows, 7 columns are there. Print only column names in the data set. I'll use names. NAMES, sales by country. Enter. Print first 10 observations or print first few observations. That's what we mean. Sales by country. If you want to print first 10 observations, I think you have to give comma n equal to 10. That's how you can print first 10 observations. Print last 5 observations. The same way, tail of sales by country. Get the summary of the data set. We can say summary of the, even before the summary, it's better to get the structure of the data and the variable types. Sales by country. This is the structure of the data, some of them factors, some of them integers, etc. Get the summary of the data. You just say summary of sales by country. That is the summary of the data. In sales channel, in fact, the original data has direct sales channel 91, online 511, retail 396. Describe the field unit sold cost country. That is simply we have to get summary of sales by channel, sales by country, units sold. Cost country need to be dealt differently. You need to use table and then because cost country is a factor. These are all the countries and their frequencies. Create a new data set by taking the first 30 observations from this data. We have seen that accessing first 30 observations, that is sample sales by country, I give this way 1 to 30 and all the column. Here is the sample first 30 observations. Print the resultant data. Remove the new data set. RM sample removed. Now there is no more sample, not this one. Yes. So these are some of the basic commands and basic summary on the data set. Let's move on. Shall we move on? One confirmation from the attendance. Shall I wait on this slide or shall we move on? Subsetting the data. How do we subset the data? Let's say if there is a data set called GDP Where is GDP data? Did we miss it? Okay, anyway, we'll get it once again. So it's a World Bank data set. So I'm importing a data set called GDP. This has a lot of rows and a lot of columns. Dimension of GDP. It has 195 rows and 4 columns. So how do we subset the data? There are multiple ways of subsetting the data. We can select few particular rows, or sometimes we want to filter out based on the columns. So there are multiple options for subsetting the data. So we will try out each and every one of that. Okay. So what if I want to take first 10 rows as a subset from the GDP? So the way that I do it is first 10 rows, all the columns, and I would like to create a new data set GDP1. That's how I subset it. GDP1 has 10 rows and 4 columns as it is GDP. What if I want to take first, 4th, 10th, 12th rows only, remaining all I'm not interested. So if we are picking very particularly some of the rows, then this is the way we should do it. We have to use C operator or concat operator. So the way we do it is GDP C of first row, then fourth row, and then 10th row, and then 12th row, or maybe in 15th row, and all the columns. I'm going to store this in GDP2. Then I would say GDP2 is this one. That's how we do the subset. Go ahead, do this quickly. Once you're done with it, please ping that back in the chat window. So the data files, everybody has access to data files. The data files, I sent a separate link that is there on Google Drive. Who has data files access? You don't need to download all the data in one go. Whichever data that you require, identify it, download it. Let's say right now we require World Bank data. Identify where World Bank data folder is in that data file folder that I shared. From there you download it. Okay, I'll move on then. So there is a, by the way, anybody finish this exercise? Not yet. Okay, go on. Talking about only first two commands, GDP1, GDP2. Remaining anyway, I'm going to explain now. GDP1 is taking few rows in a sequence. GDP2 taking particular indexes, picking up some particular indexes and then making a data set out of them. And okay, now there is a way we can actually pick up only selected columns. It's not technically really the subset. Maybe, yeah, I mean, a data set with containing selected columns from the data set, that the original data set. So the first one is rows, second one is column. So I want to pick up second to fourth columns. Then I would like to store it in GDP3. So how does GDP3 look like? Let me take a head of that. So it has only second, third, fourth, two, three, four. Similarly, if I want to take only specific columns like first column, second column, and fourth column, I have to use C operator here. So that is all the rows, first column, second column, and fourth column. So that's how GDP3 works. In fact, let me say head of GDP3, first, second, and fourth column. Similarly, there is another way of doing this. That's what, if we want to take the columns, we can also mention the column names. So C of the column names that you want to get inside, the column names that you want to select. So we want to select country. I mean, if we don't know the index where the column exists, let's say country is 158th column, rank is 157th column, we don't know where they are, so we can directly use the name of the field that you are trying to get. So the country and rank, these were the. Go ahead and try it out, GDP 3, 4, 5. We're talking about new data set by keeping selected columns. Once you're done with it, please inform me in the chat window so that I can move on to the next topic. Now we can do a combination of both of these. Let's say GDP. I want to take some rows, some columns. So from 5 to 20th row, and given that I want only first column, second column, and fourth column. That's how you do it. First one is row selection, rows accessing. Second one is column accessing. I would say GDP 6. That is the new data set. That is how it is created, and GDP 6 looks like this. I'm selecting specific rows, specific columns. Similarly, I can also do this. I want to select specific rows, GDP7 that I'm creating. I want to select specific rows and exclude specific columns. Let's say if there are 200 columns, I want to select 198 columns. It doesn't make sense to mention 198 columns in one by one. Rather, it makes sense to avoid last two columns. So we can just say the columns that we want to avoid using a negative sign that works, and GDP 7. So that will select whatever rows are there that are remaining. Okay. So go ahead, try these out. Last two ones. Selecting rows and columns, selecting rows, excluding columns. Similarly, there are so many other combinations, excluding rows, selecting few columns, all those things. Once you have created GDP 6, GDP 7, please ping me over the chat window. I'll move on. Let's do an exercise quickly. You have to get the bank telemarketing data. There is one bank telemarketing data. In that there is bank underscore market. So go to the datasets folder, import bank telemarketing data, try to do these things. So every time that you do an exercise, create a new dataset rather than printing as it is. Select first 1000 rows only, then store them in a new dataset. Select only 4 columns, create a new dataset out of that. So get the bank telemarketing data and do this exercise on it. Please ping me in the chat window once you're done with it. You need to read bank telemarketing data. What are the dimensions? There are 45,000 rows, 18 columns. These are the names. As I told you, these are the first thing that you should do as soon as you import the data set inside R. Import it, see the dim, see the names. First one, select first 1000 rows only. Bank is my dataset name. Bank. Within that I want to select 1 to 1000. That's it. And then I want to store it in bank 1. Dim of bank 1. 1000 rows, 18 columns. Select only 4 columns, customer number, age, default and balance. How do you do that? Bank 2 is where I want to store bank everything but few selected columns. C of customer number, customer age, default, balance. We can see the head of bank 2, customer number, age, default and balance. Third one, select only 20,000 to 40,000 rows observations. So that is bank 20k to 40k, comma, along with the variables customer number, job, job, marital status, that is marital, comma, education. Oops, I didn't store it in any data set. So I'll say it bank 3. Dim of bank 3. 20,000 one rows are there because I'm selecting from 20,000 to 40,000 and 4 columns. Select 5,000 to 6,000 observations. Drop P outcome and Y. So I'm dropping the output variable. So simply I just say bank. This is little tricky. Observe it here. Bank of 5,000 to 6,000. Then I have to drop particular type of variables that are P outcome and Y. If I know their indexes, then that is perfectly fine. I can directly say C of the way that I have shown here. I can give C of minus that and minus this. But if we are excluding by the names, then we need to write a slight logic here. I'll take names of the bank inside this, inside P outcome and PY. Those are the ones that I am excluding. Understand the logic here. Names of the bank. What does that give? All the names, the column names. If they are in this, then I'm excluding them. So that is the logic that I'm using. So first I'll select the names of the bank. So names of the bank, and in the syntax, actual syntax for in is percentage in percentage, and C of, if they are inside this, P outcome comma y. Try to understand the logic here. Not really difficult. If this I leave it as it is, then P outcome and Y will be chosen, names of the bank and this one. But if I want to exclude them, I have to put the asterisk sign. Basically this in operation will give true, false, true, false. If the names of the bank in this one, it will give only true whenever P outcome and Y occurs. I want to take the opposite of that and store it in bank, let's say 4 dim of bank 4. Just dropped two variables. If you know what are these P outcome and Y indexes, then the job is very easy. Let's say they are 17 and 18 variable. You don't need to write all this. You simply write C of minus 17 comma minus 18 or like minus 18, which will anyway directly give dim of bank 4 as 16. Is that clear? Can we move on? This is not very obvious. I haven't discussed this, but if you spend some time. Now the question is, what if we write n without any prefix? What do you mean by n? If we write in n instead of y. So Devashish, can you send the chat to everyone so that they can understand your question as well? So the question is, what if we write n, uppercase n, without any prefix instead of y? So maybe are you trying to say, if I put here n like this, what is the difference? Is that the question? Yes. So is there any variable called n? I don't think so. So dim of bank 4, 17 variables are there because in the names of bank, there is nothing like in the names of bank, there is nothing like uppercase N. So if the name is either in P outcome or N, that will be almost excluded according to this logic. It found P outcome, it excluded that out of 18. It haven't found N, so anyway it is not caring about it. So out of 18, 17 variables are selected, one variable is dropped. Is that clear? If I write instead of N, if I write previous also here, okay, so what this logic will do, it will find P outcome, it will find Y, it will find previous three variables. If they are there in the names, it will first print them, but since we are doing the opposite of it, if they are there, those will be excluded. So if I write this one, store it in bank 5. So if you see dim of bank 5, there will be out of 18 there will be only 15 variables left because P outcome, Y and previous, if they are found names in this one, they are all being excluded. What exactly this give? I think true, false, true, false, true, false, nothing else. Simply this whole thing, if you just run only this bit inside the brackets, whatever is here, if you run this, false, 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 true, 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 last three variables, true, true, true. And I take the opposite of it, it will be all true, rest false. So we are selecting remaining name. Got it? Cool. That's how we subset the data based on the variables as well. Okay. Subset the data based on filter condition. This is what we encounter most of the times while we are working with the data sets. We get the data, raw data, and we will have one variable based on the variable condition. We have to subset the data. Sometimes we might have to select something which is budget more than 5,000, so and so month equal to August, or select the, so basically we have to select the data, subset the data based on a variable. Very rarely we take the data first few observations, last few observations. That's what we do very rarely. Most of the times we will be subsetting the data based on a particular variable condition. Let's say in the bank data, if we have to subset, most of the times there will be a condition, okay, select all the customers whose balance is more than 1500. How do we do it? We have to use a function called subset. In that function, it expects two parameters. First one is dataset name. The second parameter is the logic. The second parameter is the condition based on which you want to subset upon. Here I want to do balance, bank dollar balance greater than 1500. So that is how I can subset based on variable. Then I save it in a new data set. I'm storing that as bank subset. So once again, we have to use a function called subset. We have to give the data set name. We have to give the filter condition. That's how we do a lot of filter many a times. And then obviously this bank subset, the bank has 45,000 rows, whereas bank subset has 10,000 rows. In fact, we can give not only a single condition, we can give more than two conditions or a many number of conditions with and or in between them. What do I mean by that? I can select a subset which says there are two conditions. One is age greater than 40 and loan equal to no. Age is one variable. Age should be more than 40. Loan should be no. I want to select all such customers. So how do I write it? I write subset, then the dataset name bank, comma, age greater than 40 and loan equal to no. Let me explain you why I am writing equal to here two times. The reason for that is equal to is also known as an assignment operator in R. Till now we have been using only this type of assignment operator for our operations. In fact, we can use bank underscore subset 1. We can use simply equal to also. This also works. Equal to also does the same thing as assignment. So if we put equal to, loan will be assigned everything as no, no, no. So when you are doing a comparison, when you are comparing something, like when you want to do this kind of conditional operation, you have to use double equal to. You might have observed this in some other programming languages as well. So when you are doing an operation kind of thing here, comparison or anything, then you have to use double equal to. When you are assigning, you can directly use equal to. See this? Bank subset. This works. You don't need to write assign or symbol here. But assign symbol is a better way of doing it. So let's see how many observations are there. There are 17,000 observations inside this one. Is this clear? This is AND condition. Age greater than 40, loan equal to no. There is an OR condition as well. That means one of the conditions is true, then you can actually take that. You can consider the data. So bank subset 2. Obviously, there will be more rows in bank subset 2 than bank subset 1. Why? Because it is a OR condition. There are 41,000 rows. Go ahead and repeat these exercises. I'll give some time quickly. Once you're done with this, please let me know. So once you're done with this exercise, we will take a 5-minute break, then quickly regroup. So shall we move on then? Okay. Yes, okay. So even we can even increase the complexity, like we can put multiple conditions. It's not like just one or two simple conditions that we might have to do while we are doing with the subset. We might have to sometime take an and condition or condition together. Let's say in the same example that we have taken age greater than 40 and loan equal to no, we might have to do something like another or condition need to be added. So this is condition number one, age greater than 40 and loan equal to no, or that is first condition, or marital status, that is marital equal to single. Only either they have to be single or that is one condition, or they have to be age greater than 40, and maybe we are trying to take a particular type of data with these conditions, age greater than 40 and loan equal to no, or else marital status equal to single. Only those type of observations we want to take it as a subset, bank subset. Marital not found. Marital. This is found. Dim of bank 3. Go ahead, do it along with me. We are using one AND condition and one OR condition together in one place with the smart usage of parenthesis. Parenthesis here and there, the whole logic will be gone. Once you're done with this, please ping me in the window. Create bank subset 3. Use the parenthesis smartly. Let me know once you're done with it. Now here is an important modification or addition to the same type of example. We can actually select few columns while doing the filter. So this filter is on the rows, right? We can even select few columns while doing the filter. For that we need to use a command called select, comma, select equal to, within the concatenate operator we can select few columns. So within this I want to select P outcome, or let's say this is bank, right? Maybe I want to select age, and then loan, only I want to select these, then marital status, and then obviously customer number. We don't know the variable exactly how it looks like. Let me just get the names of the bank. I think this is the one. Yeah. So bank subset 3, if you see the head of bank subset 3, it has only these. So I have only selected a few columns, and then the remaining filter condition is as it is. So imagine a huge raw data set with numerous rows, numerous columns. You have filtered the rows based on the conditions, filter conditions, and then you have chosen selected columns using select operator. So in the subset feature or subset function of R, go ahead and do this as it is. This one. Use the same conditions but select few columns. Please let me know when you are done with this. Try to understand the code. First we are writing the dataset name, then the second one is filter conditions, the third one is the type of columns that you want to select. We are using select equal to C of column 1, column 2, column 3, column 4, whatever column that I want to pick up. Please let me know once you're done with this. Are you facing any issues? Do you want my help there? Okay, done. Everybody done with this? Now exactly in the similar fashion, if I want to draw up few variables, instead of selecting age, loan, marital status and customer number, what if I want to just draw up them? I can put negative sign in front of it. That is the advantage of subset here. In the subset function, I can use negative sign in front of C. Those will be dropped. So now in the same bank data set, bank subset 3, I can get everything except those variables. What did I do? I just want to drop few variables. Drop a selected number of variables, select remaining all. Then I can put a negative sign in front of the variables that I want to drop. Just try this out. You just need to recall the same command and put a negative sign in front of it. This will ignore these variables and remaining all will be taken, and anyway this will take care of the rows filter criteria. Done. So this is very straightforward filtering. You just need to give the dataset name, variable filter that is a rows filter based on variable, column filter based on select using select operator. So this is the exercise, lab exercise. I would suggest you to go ahead and do it when you are free, not in this class right now. But anyway, I'll solve it for you. Later on, you can try it out on your own. This is very straightforward data set, and using and or conditions you can directly do it. Okay, So what are we trying to do here? We take automobile data set. In that we have to create a new data set for all cars with city MPG, city mileage greater than 30. So basically we need to put a condition on the variable and several conditions put together, and then by selecting only few types of particular types of variables and values. So this is, if you know these commands, it's very easy to execute. So I'm skipping this exercise. If you face any issues, you can refer to the code that is already there, or still if you have any issues, then we can discuss in one-on-one. Okay, is that fine? The reason why I'm skipping is it's too straightforward. It's just a subset function that we need to know how to use it, right? Yeah. Now the most another important concept called calculated fields or derived fields in R. Let's say not every time just the number of fields or number of columns that are there in the raw data sets are sufficient for our final analysis. We might have to do some operations and create new fields while we are working with the data sets. So what do we do? So the way we should do it is, first we need to access the field. Let's say there is a variable called x1, there is a variable called x2. I want to calculate sum. Then what can I do? I have to access first variable dataset $x1 plus dataset $x2. Then I have to assign it into a new variable called sum, which is again stored in dataset. Similarly, dataset $mean, dataset $mean, dataset $x1, dataset $x2. You calculate and store it in mean, right? So let me show you an example. Let's say in the same auto data set. So let me get the auto data set. Here is the auto data set. What are the number of rows in it? 205, 26 variables. There are so many variables. This is the auto data set. It has symboling, normalize, this, that. Let me see the head of auto data set. Hopefully we can make something out of it. Looks like this is automobile data set. It has symboling, normalized losses, make, RDGD and all that, fuel type, the number of doors, body. It gives a complete information about automobile, a particular uh, automobile data set. This one, body style, engine type, number of cylinders, fuel type, etc. Okay, what I want to do is I want to calculate something called area. Okay, so I have the length, width and height. Length, width and height. So length, width and height of the car that I have. Can I calculate area and store it inside this data set as well? So auto data set, I'm calculating a new variable called area. How am I calculating? Auto data set dollar length. That's how I access length. Star auto data set dollar width star auto data set dollar height. So if you see here, there is nothing like area. Price is the last variable, but we are trying to create. So to remove ambiguity, I'll try to make it easy to read. So I'll put even parentheses, length, width, and height. I'm creating a new variable here. Auto data set area is just calculated. There is a new variable that is added. In the bank data set, there is a in the bank dataset there is a column called balance. If I want to create balance new by taking 80% of the balance, I can write bank dollar balance underscore new, which is by taking bank balance ka 80%. Right? Now you can see in the bank data set There is a new variable balance new. That's how you create new variables. You write dataset name dollar new variable name. Quickly create these two variables, import auto dataset. You already have bank data. Once you're done with these two, please inform me. You're done with it. Please let me know once you're done with this. Are you done with this? Not yet. Okay. Please let me know, ping when you are done with this particular topic. Am I audible, everyone? Yes. Then the next topic is if then else statement. What are we doing here? We are trying to learn all the important concepts or topics or syntax in R. They're not really hard in terms of their logic and their functionality. It is just that we already know how to do all these operations in some other tool, one or the other. It is just that how it is done in R, that's what we are trying to understand. That's why it's easy to learn R when you know any other programming language like SAS or any other analytical language. If you are comfortable, then it's easy to learn R. It is just that, what syntax is changing here. That's the only thing that we need to identify. Remaining everything flows in a streamlined manner. If once you start using it more often, you will identify that it's very intuitive, easy to get. Okay. Now, if then else, how it works? It works like somewhat Excel if then else. So you have to write if else, you have to write the condition, you have to write what is the value if the condition is true, you have to write what is the value if the condition is false. Look at this data set. What is the structure of horsepower? So this is horsepower in this particular data set. Are there any missing values in horsepower? Yes, there are two missing values in horsepower data. In auto data set, there is a variable called horsepower. So for a car, there is this horsepower variable, right? Yeah, there are some two missing values somewhere. So what we want to do here is whenever there is a missing value, we want to replace it by -1. Or sometimes we might want to replace the missing values with the average of the rest of the values. Sometimes we might want to replace the missing values with the median of the rest of the values. So what are we trying to do here? If there is a missing value, we'll try to very distinctly replace it by -1 so that later on we can identify it quickly. First see it, then you can do it. You have to write if else. If else is a function. What is the condition? Is dot na if this particular variable from the auto data set horsepower, if this is na, that's it, is na. If that condition is true, then you put -1, or else you leave it as it is. That means auto data set dollar horsepower. So I'm creating a new variable using all these conditions. Instead of making changes in horsepower, I'm creating within auto data set, I'm creating a new variable horsepower new. I'm creating a new variable here using if else. If this is missing, is na will be true. Then when if this horsepower is missing, so the value when it is true, that is -1, value when it is false, that is leave it as it is. So I'm creating new variable horsepower new. Now if you see the structure or the summary of horsepower new, first we will see horsepower. It has two NAs. Now whereas minimum value is 48, now that the new one that we have created that has maximum 288, there are no NAs, minimum value is -1. That is just to demonstrate to you the usage of if else. I'll give you one more example, then I'll give you time to try out this. Similarly, we have something called peak RPM new. Let me see summary of auto data set dollar peak RPM. These are variables related to simply cars. It has also two NAs, so we'll follow the same pattern. I'll write if else is dot na if this particular variable peak RPM is missing, then if that condition is true -1, or else you leave it peak RPM as it is. I would like to store all this inside a new variable called within auto data set auto data set dollar peak RPM, peak dot RPM underscore new. That's how I want to store it. Create it. Now you can see the summary of auto data set dollar peak RPM new. It doesn't have any missing values. Try out these two examples. Let me know once you're done with them. Once you're done with it, the next topic is sorting the data. How do we sort the data? Sorting is pretty simple here. We need to use a variable called order that will sort the data. Just know a function called order. The way we sort it is we just say the dataset name, and then within the variable selection we just say order based on what variable we want to sort it out. Let's say there is this dataset called online retail sales, right? Let's say, or here itself auto data set. If you want to sort it on a particular variable, I just need to write order, the variable name on which you want to sort, and then you give the rest of the variables that you want to select. Simply you just say dataset name, and then order is the function that you want to use. So let me show you a simple example here. So we will get the online retail data. So here is the online retail data set. It has so many observations, looks like. So how many rows, how many columns are there? On There are 5,41,000 rows or 541,000 rows, and then what are the names? 8 variables are there. These are the variable names. So what am I going to do? I'm going to sort this data set based on a variable called unit price. There's a variable called unit price. I'm going to sort it based on unit price. Right now this data set is not sorted based on unit price. So let's have a quick look at it. Online retail data set. This is how it looks like. Where is unit price? Unit price 2.55, 3.39. So this is not sorted based on unit price. We can create a new data set called online retail underscore sort. That is a new data set that I'm trying to create. The way I do it is first I take the data set online retail, then I use the function called order, then I have to sort it based on unit price. Where is unit price in online retail? So remember to put the dataset name, dollar, variable name, unit price, and then comma, all the variables I want to take in this process. Online unit price. So online retail sort will be sorted based on unit price. Done. Where is the new data set? Online retail sort. It is a new data set. What we need to focus on is unit price. It is sorted in the ascending order. What if you want to sort it in the descending order so that the highest unit price is here, lowest is in the bottom? So you can use the same command, maybe online unit price sort 1, or I'll create the same data set, whereas here this time I'll put in the order negative sign. So it will be sorting in the reverse order, which is descending order. The highest will be first, the lowest will be last. Unit price, the highest unit price is here, lowest unit price is below. So we have to use a function called order, O-R-D-E-R, order. Is this clear? Yes. Try it out. Do you want to try it out? Shall I move on? You want to try it later? Just checking. Because I feel these are pretty much simple commands. Once you uh, see them even after the class, you should be able to understand them quickly. Yeah, we'll try later because there are too many things that we need to cover. Yeah. Then identifying and removing duplicates, one of the important concepts while we are dealing with the data sets. How do we identify duplicates and remove duplicates? So there are inbuilt functions inside R, so we don't need to really worry too much about identifying duplicates and removing duplicates. So let's say the way we do it is first we need to get the duplicate indices. Okay, where are the duplicates present? Okay, then we have to find out whether unique data or duplicated data. What do I mean by fetch the duplicate record indices? Let's say I have this telecom bill data. Okay, this bill data has so many observations and some rows. Okay, some rows and some columns. There are 9,000 rows, 7 columns are there. Head of bill. So this is how the telecom bill data looks like. Are there any duplicate records in this? In 9,400 rows, it's very difficult to identify by naked eye. So what do? We have to use a function called duplicated of bill. What this function does, it simply gets the indices whenever it finds, like Each row will be taken, it will be compared with rest of all the rows within this data set. If that row is a duplicate, it will be shown as, if it is for the first time, it will be left as it is. If it is second time occurring, then it will be considered as duplicate. So this, then I will say dupes in bill. So I'm just storing it in this particular vector, or it can be anything. Just I would say dupes indexes. Okay, so what this dupe indexes contains, it contains true, false, true, false, true, false. Whenever there is a duplicate, it will be true. Whenever there is no duplicate, it will be false. So from here also it is tough to make out. Then what we'll do, we'll try to see the summary of dupe indexes. There are 9,452 false. There are 10 trues. What does that mean? Dupes indices, it is 9452 false, 10 true. What exactly that means? Tell me. What do you understand from here? Dupe indexes I have created from duplicated function. This function gives whenever there are duplicates, it will take the value true. So can I say there are 10 duplicates in this whole duplicate records in this whole data set? Yes, there are 10 duplicate records in this whole data set, but I know only their indexes now. Okay, these are it is stored as indexes only. How do I get the duplicate records? I can get it by, and if I want to store them in bill dupes, okay, then I can do it by using bill data. Okay, this is the bill data. Then fetch the indexes, dupe indexes. So dupes indexes, comma, all the columns. So the dupe indexes, wherever it is true, that is those 10 rows will be coming. Is that clear? Am I making sense? Here, this dupe indexes takes 9,400 falses, 10 true, so I'm taking only those. So whenever it is true, that will be fetched from the bill data from these indexes, right? Now bill dupes, if I print that, it will definitely have 10 rows. These are the rows that are repeated, not among themselves, they are repeated. uh, Totally there is one more row that is already exactly the same way inside the data set, bigger data set. These are the 10 duplicates. Is that clear? We have to use duplicated function. Now there are two types of duplicates. One is duplicates, overall record level duplicates. You know that, right? Record level duplicates and primary key, the key level duplicates. If sometimes a key is repeating twice, something like customer ID or something like employee ID, in a month we shouldn't get two salaries for an employee ID, even though salary amounts are different. So sometimes we can't tolerate even a single primary key repeating twice. So how do I get duplicates based on a key? So simply instead of taking duplicated overall dataset bill, what I'll do is I'll take duplicated on the variable. So I use duplicated. So I will say dupe bill on customer ID. That is the new variable that I want to create. I would use duplicated function only, but this time I'll use on the bill customer ID. If I write just bill, overall record level will be taken as duplicates, duplicate indices. If I'm using based on customer ID, I might find some more duplicates. So earlier there were 10 duplicates that are record level. At customer ID, how many times it is repeating? How many duplicates are there? There are 73 duplicates based on the key. Do you know the difference between duplicates overall record level, duplicates based on the key? These are the duplicates based on the key. When the customer ID is repeating, when a primary key is repeating, that is when we say duplicates based on the key. Again, we are storing them in duplicate customer ID. If you just want to access only those 73 records, what you can do is you write the dataset name and those indexes anyway you have created them, and then create the new dataset. And if you try to print this new dataset, it will just have 73 observations and all the rows. That is duplicated records based on the key. How do we remove duplicates? This is fetching the duplicates. How do we remove duplicates, or how do we get the unique values? So instead of fetching the duplicates, you can fetch the unique values. That means duplicates in bill we have created, or dupe indices. So earlier I was writing like this, right? Bill, then dupe indexes. That's how I was writing, and I was fetching all the duplicate values. There were 7 such duplicate values or duplicate level records. What if I want to get all the unique level records? I just do the opposite of it. So I will write bill underscore unique. Bill underscore unique. Now instead of duplicates, I take the opposite of that. How do I take the opposite of that? Exclamatory. So I take the opposite of that and then enter. Bill unique will be bigger now. Earlier we got bill dupes, now this is bill unique by removing those 7 record level duplicates. Or else if you want to do it on a key, you have to mention the key indexes here. Or else you can directly use unique function that I generally don't suggest. This has more command over what we are doing. Like, we know what we are trying to do here. Is this clear? Is this clear? Yes, yeah. So there is an exercise. Since you have already understood this, you have to import the telecom complaints data, and then telecom. I did the exercise on bill data. You have to do it on the complaints data. It's pretty straightforward. Go ahead and do it. Okay. Then in the next class, we discuss the remaining concepts. We're going to